Hello everyone. In our previous lecture we had discussed the liquid limit. What is the need and scope of the determination of liquid limit, then its test procedure, what are the apparatus required, and also total procedure of the test. And in today's lecture again we are going to discuss about the next limit. This is the plastic limit. Notation is WP or PL, plastic limit. So let us discuss. Plastic limit is the water content corresponding to an arbitrary limit between the plastic and the semi-solid state of consistency of a soil. Already I have told about in the figure. So this is the limit between the plastic state of the soil and semi-solid state of the soil. So it is defined as the minimum water content at which a soil will just begin to crumble when rolled into a thread approximately 3 mm in diameter. So this is the actual definition of the plastic limit of the soil. Then what is the need and scope of the determination of plastic limit? As soil is used for different purposes like making bricks, tiles, soil cement blocks, also for foundation work. So it is necessary to determine the plastic limit of the soil to know its different properties. Next is the apparatus required for the procedure. So porcelain disc, squeeze bottle and spatula, weighing balance, ground glass plate for rolling the specimen. This is the plate, this is the squeeze bottle. With the help of this squeeze bottle we can add water to this soil sample in the porcelain disc slowly as per our requirement. Containers to determine the moisture content. These are the containers which we use for determination of water content. Oven thermostatically controlled with interior of non-corroding material to maintain the temperature around 105 degrees centigrade and to 110 degrees centigrade. Already I have told about it in a previous lecture. So these are the basic apparatus which we use to determine the plastic limit. Test procedure. So here we have to take 20 gram of air dried soil, not the oven dry, normal dry or air dried soil, passed through 425 micron IA sieve into an evaporating dish. Then we have to add distilled water into the soil and mix it thoroughly to form a uniform paste. That means the soil paste should be plastic enough to be easily molded with fingers. And then the plastic soil mass should be left for enough time to allow water to permeate through the soil mass. Then we have to prepare several ellipsoidal shaped soil masses by squeezing the soil between fingers, and the each ball which we prepare are nearly 8 gram of this plastic soil mass. Take one of the soil masses or soil ball and roll it on the glass plate using your fingers like this, as shown in this figure. The pressure of rolling should be just enough to make thread of uniform diameter throughout its length, and the rate of rolling shall be between 60 to 90 strokes per minute. The continue rolling until you get the thread diameter of 3 mm. When a diameter of 3 mm is reached, the soil is remolded again into a ball. This process of rolling and remolding is repeated until the thread starts just crumbling at a diameter of 3 mm, and the crumbled threads are kept for water content determination. And so at least we have to repeat this process 3 times and take the average of the results calculated to the nearest whole number. So this is the whole procedure to determine the plastic limit of the soil. Next is the shrinkage limit, WS or SL. Its notation is WS or SL. So shrinkage limit is defined as it is the maximum water content at which a reduction in water content will not cause a decrease in the volume of soil mass. So after also reduction in the water content of the soil, the volume of the soil mass remain constant. It is lowest water content at which a soil can still be completely saturated. So this is the shrinkage limit, definition of shrinkage limit. Another definition, plasticity. What is plasticity? So plasticity is defined as that property of a soil which allows it to be deformed rapidly without rupture, without elastic rebound, and without volume change. So this is all about the plasticity. Next, Otterberg indices. Different indices are Otterberg indices. So let us discuss one by one. So first is plasticity index. Notation is IP. It is the range of consistency within which a soil exhibits plastic properties is called plastic range and is indicated by plasticity index. So the plasticity index is defined as the numerical difference between the liquid limit and the plastic limit of a soil. So IP equal to WL minus WP, or IP equal to, we can also write LL minus PL. And when the plastic limit cannot be determined, the plasticity index is reported as NP, that means non-plastic. And when the plastic limit is equal to or greater than the liquid limit, the plasticity index is reported as 0. So you have to remember this one. And in case of the sandy soils, basically plastic limits would be determined first. So this is the plasticity index. Next is the consistency index. Notation is IC. The consistency index, or its other name is relative consistency, is defined as the ratio of the liquid limit minus the natural water content to the plasticity index of the soil. Like this, mathematically it is shown here. IC equal to liquid limit WL minus W by IP, plasticity index, where W is the natural water content of the soil. If consistency index of a soil is equal to unity or 1, it is at the plastic limit. We consider it in the plastic limit state. Similarly, a soil with IC equal to 0, if the consistency index we found that it is 0, that means the soil is in liquid limit state. Then if IC exceeds unity or more than 1, the soil is in a semi-solid state and will be stiff. So a negative consistency index indicates that the soil has natural water content greater than the liquid limit and hence behaves just like a liquid. Then third one is liquidity index. So The liquidity index or water plasticity ratio is the ratio. It also expressed in percentage of a natural water content of a soil minus its plastic limit to its plasticity index. So mathematically it is shown here IL equal to W minus WP by IP. That means natural water content minus plastic limit minus plasticity index. So this is the definition of liquidity index. The next is the toughness index, IT. It is defined as the ratio of plasticity index to the flow index as shown here. Mathematically we can write IT equal to IP by IF. Then last one is the flow index, IF. Again IF equal to, this is the formula, W1 minus W2 whole divided by log base 10 N2 by N1, where W1 equal to water content corresponding to the number of blows N1. Then similarly W2 equal to water content corresponding to the number of blows N2. And the values of N2 and N1 corresponding to the number of blows. So hence if IF becomes equal to the difference between the corresponding water contents. Thus, if the flow curve is extended to either end so as to intersect the ordinates corresponding to 10 and 100 blows, the numerical difference in water contents at 10 and 100 blows gives directly the flow index. So this is the formula to find out the flow index of soil. So these are the different indices of soil, or these are known as Atterberg indices. So in next lecture we will solve some problems based on this formula. For this lecture this much. Thank you.